So let's begin. Today we shall take up three topics. First one is smart pointers, and second is how do you do typecasting in a safe way, and third is what is operator overloading. Okay, so these are the three things we shall try to cover up today. So what are these smart pointers? We know we use pointers to point to objects which are created dynamically, and if you use regular pointers you have to deallocate the objects yourself. So what these smart pointers do is that you don't have the burden of deallocating the memory. And when the reference variables go out of the scope, automatically the objects will be deleted. Okay, so smart pointers are basically template classes which have all the necessary constructors and methods using which the memory allocation and deallocation happens automatically and there is no memory leakage. So let's consider this example. Let's say we have a class student with 3 data members and there is a constructor to initialize the data members, and there is a display method. Now if I create, the usual way to create the objects is using a reference variable and then say new student like this. Okay, so you will pass various arguments like to BU21 CS001, some USN, some name, and then the semester, let's say this. Okay, so if you create the objects using the new operator, then you have to delete this reference variable to deallocate the memory. Okay, so instead of you deallocating and managing the deallocation process, what you can do is you can use one of these pointers. So there are three types of pointers: unique pointer, shared pointer, and weak pointer. So we shall see each one of these. So let's see the unique pointer first. So for this you have to include the memory library function hash include memory, and then you just say unique. Since it is a generic class, you have to specify the type of the pointer that you want. So currently I want pointer of type student. So you have to say unique underscore ptr, that is the generic class name. Okay, and then you can give any variable name p, and then you have to use make pointer or make unique, and then specify all the data values. So here you can specify the USN, then some name, and semester. So what happens here is your objects get created and a smart pointer is assigned to this object. As you know, this object is created in the heap. Okay, so p is a smart pointer because once this pointer p goes out of scope, that is when main ends, automatically the reference count to this object will become 0, and there is a mechanism to delete the memory allocated to this object. Okay, so you don't have to say delete p anywhere. Okay, now if you want to check whether it is working fine, you can just say display. Because it's a pointer, I should use a arrow operator here. Okay, so if I run the program should work fine with the message with all the data that we have given, demo of unique pointers, and as you can see object destroyed, which is coming from the destructor here. So I did not say delete anywhere, automatically the object got deleted. Do you see this? Hello?
Yes, sir.
Okay, okay. So it is another way of creating objects and making the pointers point to them, and you don't have the burden of deallocating the memory. Now, one problem with this unique pointer is that you cannot pass on this ownership. Now, P is the owner of this object. You cannot pass on this ownership to another pointer. Let us say you have another unique pointer. Again of the same type. Let me call it as P1. You cannot say P1 equal to P. It means you cannot directly assign pointer P to P1 because this pointer P is unique. At a time, only one pointer point to any object that you create. Okay, but how then I can make P1 still point to the same object? So there is a different way. That is called as changing the ownership. The way to do that is you have to use the method move and then pass the variable P. Now what happens is P1 gets the ownership and P loses the ownership. It means P will be a hanging pointer or a dangling pointer, and P1 will be pointing to the same object which P was pointing earlier. So this move method will help you to change the ownership of the object. Okay. So now if I run the program, I will get exactly the same effect or same output. As you can see, same object is getting displayed. Okay, so unique because the name only indicates unique. It means every object will have exactly one pointer pointing. Okay, so this is one type of smart pointer. The second one is shared pointer. It means more than one pointer can point to the same object. Alright, so let's see how I can create a shared smart pointer. For that you have to say shared and then typecast or specify the type of pointer you want, call it as sp1, and here make shared. Instead of make unique, you have to say make shared.
Sir, before going to there, I
Yeah.
just have one particular thing.
Okay.
Instead of P1 is equal to move of P, can we just have something like P1 is equal to P?
That's what
And
I told you. No, it doesn't work. It will give error. You cannot do like
okay,
that. If you try to do it, you will see some error coming up here.
okay,
It says some error here.
okay,
Cannot be referenced. It is declared deleted
duplicate.
function. Okay. So
Okay,
direct, it means two pointers cannot point to the same object.
understood, sir.
Okay, you have to give the ownership to another pointer using the move method.
Move method.
Got it, no?
Yeah,
Yeah. Now, in a shared pointer, you don't have to say move. You can directly make two pointers point to the same object. So here again, I'll create a different object. Let's say 2 BM22 CS002 whatever. So this is a new object and it is pointed to by shared pointer. Okay. So this is the only pointer pointing to that object. If I say arrow display, now both the data will be get displayed and we shall see how to make two pointers point to the same object after this is verified. Okay. So second object is displayed here, right? And automatically, as you can see, object destroyed is coming twice because both are smart pointers. So object is deleted automatically when both of these go out of scope. Now if I want to make another pointer point to the same object, shared pointer student sp2. Now I can make sp2 directly point to sp1 because it is shared. You don't have to say move. Okay, and then set ASP2 here, it should work. Okay. Did you get the difference between the two, unique pointer and shared pointer, or you have some doubts?
Understood, sir.
Okay. So shared pointers you have to use when you want to make more than one pointer point to the same object. Alright. Now there is a third type of pointer is called as a weak pointer. Now whenever you make a shared pointer, there is a uh, count that is maintained. How many references are there with the object? So let me display that first. So you can say count equal to sp1 dot use count. If I display this, you will see the count will be 2 now, because sp1 and sp2 both are pointing to the same object. Okay, so the count is 2. Alright. Now if you don't want the count to increase but still you want to have a reference, then you can define a weak pointer. So you say weak pointer student WP, and this WP you can make it point to SP1 again. Alright. But if you use weak pointer, this is only referencing the object. Using this you cannot execute the methods. It doesn't add to the reference count also. If I say sp1 use count, the use count will still be 2. Let's see whether we get the same. As you can see, the weak pointer will not increase the reference count, but it will be just referring to that object. Right? Now what is the utility of this weak pointer? This is useful whenever you have a linked list. You all have learned a doubly linked list, right? So one node pointing to the next and the next node is pointing back to the previous. So there if you use these shared pointers, okay, the reference count will be 2, and since one is pointing to each other, when the variables go out of the scope, the objects will not be deleted because the reference count is decremented by 1 only. Okay. Now in that case you have to use weak pointers. So weak pointers do not increment the use count, whereas they will help you to refer to the object. Alright. So the utility of this weak pointer we shall see when we study data structures in detail, where we will actually implement a doubly linked list and see how weak pointer is helpful there. Okay. So for now you understand that there are 3 types of smart pointers. One is unique pointer, second is shared pointer, and third is a weak pointer. Alright. Okay, so would you like to try this out or we will proceed further? I think so we can proceed further, right? I will share this source code with you. Alright. Now let's see. Before casting we shall see what is this overloading an operator. We have seen overloading methods and all, right? So overloading operator, I haven't explored that until now, because there are some major concepts had to be covered. Now let's take the example of a class wherein I want to model storing the complex numbers. All of you are familiar in mathematics. We have what are called as complex numbers, which have real part and imaginary part. Okay, so we normally write them as a plus ib. Okay, so where I is square root of minus 1. In that case, we will be storing real and imaginary part separately as double data type, and there is a constructor to initialize this object. Alright, now we know how to create the objects of this class, complex C1, complex C2, and this. Now normally if you want to add two complex numbers and generate the result, how you would have written the method? You would have written the return type as complex and just say add, and within this you would have written complex C1 comma complex C2, and within this you would have written return complex C1 dot real plus C2 dot real. So you would add the real part separately and imaginary part separately. C1 dot imaginary plus C2 dot imaginary. Okay, so this would have added the two complex numbers and returned you the third complex number. So you could have checked that C complex C3 is equal to C1 dot add C1 comma C2. Okay, you could have avoided using complex C1 here because C1 is already there, but you could have done a simplified add also. Now the thing is, if I want to display, I should have a display method here, void display, where you want to display the real part, then the imaginary part with a I in between. It should be right now, assuming that the imaginary part is always positive, so I'm putting a plus I there. Yeah, so this will display the complex number. Now if I say C3 dot display, it would display the two numbers. Okay, so we have the first two complex numbers as 2.4 and 4.5, the real values. When we add, it becomes 6.9. 5.2 and 3.2 add, you get 8.4. So we are getting the result here. Now this is the usual way you would have done it. Now what suppose if I wanted to use a syntax like this? Suppose I want to write like this, just as I would use basic data types. I want to write an expression like this: C3 equal to C1 plus C2. Okay, I should be able to do this kind of a thing, right? So this would be more meaningful. That is, the user defined types are added just as you would add the basic data types like int, char, float, whatever. Okay, so to do that, you have to instead of complex add, you have to use operator here with plus and then define complex C1 or whatever. So within this you would return this dot real. In fact, you have to use the constructor of the class complex this dot real plus C1 dot real comma this dot imaginary plus C1 dot imaginary. It is giving this anyway is not required, it's directly available. Okay. So here I am writing a method which is a overloaded operator. The plus is redefined. The meaning of plus is redefined using this particular syntax. Now this would help you to write syntax like C1 plus C2 equal to C3. Alright, so let's see whether this works fine. Yeah, so this will also work exactly the way we wanted. So do you see the usefulness of the overloaded operator? Okay. So similarly I can write overloaded minus also. So if I say complex operator minus complex C1 or just C, that is also fine. It's just the name of the variable. So return complex real plus C dot real comma imaginary plus C dot imaginary. Okay. So only problem is if the imaginary part after subtraction, if it is negative, then you will have a problem here. It will show plus. Okay. So instead you can just check if imaginary greater than 0, you display like this, else you see out real with little space and this imaginary. So if it happens to be a negative number, then that negative part will be taken care of by the second part, the else part. Okay, so let's see now what happens if I say C1 minus C2. Okay, so now since second number imaginary part is smaller, you will still get what happened? C1 minus C2. Okay, it should be minus right here. While implementing, we should subtract the real parts and the imaginary parts. Okay, so as you can see, minus 2.1 I2, but if I increase this to, let us say 8, then or 9, whatever, slightly larger value, so the second part, imaginary part, will have a minus sign. Okay, the I part is not getting displayed, so you have to have now there will be a problem of I coming after this. So what I can do is this I can be displayed after the imaginary number here for uniformity, otherwise that I will come before the minus sign. So here I can display the symbol. So now this should be okay. So minus 2.1 minus 4i is what you should get. So are you with me so far? Hello?
Yes, sir.
Okay. Okay.
Sir, can you just use 5.2 over there at the imaginary part?
Where here?
Yeah.
So you should get 0, no?
Yeah. Uh, how it comes, I just
It will display minus 2.1 minus 0.
minus 0. It will just use it by.
Yeah, so that is a problem here.
Yeah. Okay.
So in that case, it should be here. It should be greater than equal to 0.
Greater than equal to 0.
Yeah. Isn't it? Okay.
And have to add I plus symbol before ing.
Yeah. So those small modifications you have to do. Okay.
Sure, sir.
Now this is okay. Now you are saying C3 dot display to display the value. Better still would be I should be able to say C out C3 like this. It means I should be able to send the entire object itself to C out. So here I need to overload the output operator, that is less than operator. So I should be able to do that here. So for that you have to say O string. So there is a specific syntax that we need to follow. Then say operator less than, then O string ampersand out, comma complex C, and here you have to say out C1 dot real C1 dot or C dot imaginary and L, and you have to return out like this. And one important thing is this has to be made a friend function. Okay. Why? Because this out is not out is an object of output stream. This is not part of complex class. Okay, this is an object of output stream. This output stream is accessing your real and imaginary part, isn't it? So for that you have to make it a friend function, so that this out object has access to real and imaginary part of your complex number. Okay, so now you don't have to call this display function. This should work exactly the way the previous code worked. So let's see whether it does that trick. As you can see, it is still displaying. Only thing that I is not coming because I have not displayed that I here. So you should have added I here at the end. So here again you have to take care of the sign, right? So exactly the way you did it here. So you must put this whole thing here. Instead of C out, you are using out. This out is an object of output string. Okay. So this is overloading of the output operator. That is, you can output exactly the way you output to normal variables. Okay. So in this case, you can use the third variable, or you can directly say C out like this. Should this also be working? Isn't it? You can say C1 plus C2 or C1 minus C2. Okay, so this also works. Of course, there should be a plus sign here. And if there's an imaginary negative part, you can check that if img greater than 0, this is what should happen. otherwise you should take care of the negative part. It should be c dot ing, else you can copy all this and put a minus sign here, right? So if you make it minus here, let's see what happens. Okay, so minus 2.1 plus 0i. Actually it should only display minus 2.1. Okay, so that is another special case you have to handle accordingly. Alright, so if it is a big negative number, it should work perfectly fine now. Yeah, one more negative sign is coming. So here you don't require minus sign, isn't it? Because you already know imaginary part is negative, so you can do away with this part. So these are some small refinements you can do. Okay, so this is a negative complex number. Alright, so we understood how to implement overloaded operators. We saw plus, minus and this less than less symbol. Alright, okay, yeah. So are you familiar with writing the methods outside the class? Implementation of the methods outside the class. I think I have not told you this. For instance, this display function, it is defined right here, right? So what I can do is I can only declare it here, and I can shift this implementation outside the class using the scope resolution operator. I should say void complex colon then this display function. It means the methods can be defined outside the class, but only with the scope resolution operator like this. Okay, so this is one other way of implementing the methods outside the class. Whenever you are exposed to some code, you will see some methods declared only here, and the definition happens outside the class. Okay, so both are one and the same. The advantage is this class will contain only function declarations. So let us say there are some 100 methods here, so all methods will be there with their signatures. The implementations will be outside. Now that will help you to get a quick view of what all methods are there in the class. So if you have implementation also in the same class, the class becomes so big that you don't get a big picture of what all is there in that class. So the details are all written outside, and normally the method signatures only are found inside the class. So this is one variation you will normally see in most implementations. All right. Okay. So are these things clear to you? Operator overloading. This concept is clear. Hello.
Yes, sir.
Okay. Okay, now what remains is typecasting. Now typecasting can be done statically or dynamically, and there are two other variations. That is, if you have a variable with const keyword, you can do typecasting and remove that const, and there is a reinterpret cast. So these are the three important cast operators which you can use to safely typecast the things. Now static cast is used whenever there is a straight conversion between data of same type, like int float, float int, or double int, double float, like that. Okay, so let's see one simple example of this static cast. Let us say we have double dpi, which is 3.142 like this. Okay, and then there is a float variable f pi. Okay, so normal typecasting, what you do, you say here float and you do dpi, right? This is how you do it. Okay, but this is has to be carried up to runtime, and then the conversion happens. Now instead, if you want to do this at compile time only, then you can make use of this static cast. So here you have to say static cast and mention what type of conversion you want. You want to convert to float, and then here you mention the object which you want to typecast. Okay, so now if you say cout pi value equal to fpi, now advantage is if you have lot many of them, so you don't have to do it at runtime. At compile time only this conversion happens, and then the float value will come out correctly. Okay, so there is no loss of precision. This is the double precision and this single precision. Okay, so if conversion is between integer type, float type, and data of same type, then you use static cast. Okay, however, if you have class relation between two classes, that is one class is inherited from another. Now you have seen upcasting and downcasting, right? So let us say there is a base class with only one method show, where it is saying I am base class show, and if I derive from this base class derived class, and in this I override that show. Okay, so there is a relation between these two classes. Now here normally what you do is we declare base class pointer. Okay, and we create object of derived class, right? This is what we do. Is this permitted? Base class pointer pointing to derived class object. Hello? Are you there with me?
Yes, sir, we are.
Okay, all of you have become silent, so I don't know what is happening from your end. Okay, so here this is perfectly fine, that base class pointer point to subclass object. So which method do you think will be executed? Is it the subclass object or base class object method? Because in the base class it is virtual here, it is implemented, and subclass it is overridden. So which method will be called here? Faisal?
Derived class method.
Pardon?
Derived class one, I guess.
Are you sure? You should be dead sure by now, right? Okay, let's see. Yeah, I am derived class show, right? So that is because P, though it is pointer of base class, it is pointing to object of subclass. So subclass definition exists and it is overridden method. So subclass method will be called. This is okay. All right. Now, what if I have a derived class pointer and I want to this derived class pointer should be typecast using dynamic cast. and this type is derived, and this is P. This derived should be a pointer. Okay. Now what is happening here? I have the derived class pointer. It should point to same object as base class pointer is pointing. Okay. Yeah, because P is of type base class, it should be downcasted, isn't it? It should be cast to derived pointer. So there it cannot be done at compile time, because what comes here depends on where P is pointing to. Okay, since P is pointing to subclass, now this conversion happens correctly. And if I use DP instead of P, you will get again I am derived class show here. Correct? Do you see this happening? So here the conversion cannot be done at compile time. It cannot be a static cast. It has to be a dynamic cast. Okay, so that you must remember. Now what if this is base? Okay, so you cannot make base class pointer typecast to subclass pointer. Let's see if I try to do that, what happens. You will not get any output. Okay, because this conversion will return null. So DP will be null because that conversion fails. Alright, so this has to be derived, and only then the type conversion happens correctly and it will work fine. Alright, okay, now const cast. Let us say we have a method show value const int star x, and in the main we have a variable a equal to 10, and you just call show value and pass address of a. Now since it's a constant pointer, I cannot change the value of a using star x equal to 20, isn't it? It will not allow, as you can see here. Expression must be modifiable L value. Because it is const int star, you cannot modify the content of a memory pointed to by x. Now if I still want to modify, then this const has to be somehow removed. Okay, so to do that, you can take one more variable here, int star y, and here you should use this const cast. And then use y to modify. Okay, now when you come back and display value of a, it should be 20, right? Now if you do this, yeah, as you can see, the value of a got changed to 20, right? So the const keyword is removed by this const cast. That is, you are able to convert a constant pointer to a normal variable pointer using this const cast typecasting. Okay, so is this fine? Okay, so these are some small features which are available in C++. You should be aware of. Whenever you encounter such things, you should know what these things are. Okay, so reinterpret cast is one other type of casting which is useful in some cases. Let's say you have int ch, let's say int b is equal to 65, something like this. Okay, now if I want to reinterpret the 65 as a character data type, then I should be able to convert this to char type. So I should say char star c equal to what is the type of casting? Reinterpret cast. So I have to reinterpret this. Reinterpret cast as char star, and within this you have to pass b. Okay. And if I say c out star c, what do you expect? The ASCII code of A is 65, so you should get capital A on the screen. What went wrong? It's not showing in output. Just a minute. Okay, now let me check the syntax. This print value, dynamic cast, and reinterpret cast. Char star c is correct. Is it a problem with this? Let me check. Everything else is working. Only problem is this: it is not able to reinterpret this as unused C. That is fine. Char star C. Unused variable C. Let me check ch and then there is some problem here. I'm not able to figure out what is wrong. This I tried yesterday, it's all working fine. So only thing is what you should remember is you can convert an integer type into a character type. Okay, so by using reinterpret cast. Alright, so this is these are the three conversion or four conversion functions which are available in C++. Alright, so to summarize what we covered today is that in the program here we saw what are smart pointers. Smart pointers allow objects to be pointed to by pointers, and when they go out of scope, the memory is deallocated automatically, so there is no memory leakage problem. And unique pointer, you cannot assign it to any other pointer just like that. You have to change the ownership by using the move method. And if it's a shared pointer, fine, you can make any number of pointers point to the same object. And there is a weak pointer concept which allows you to restrict the number of counts referring to that object. This is useful in doubly linked list. And we saw what is operator overloading. We saw operator overloading, plus operator, minus operator, and less than operator. And only what you need to remember is whenever you override the less than output operator, you must make that function as a friend function. Okay. And we saw different types of casts: dynamic cast, static cast, and reinterpret cast. Okay, so all these things are very useful things in C++, and you should be aware of the meaning of all these three things. All right. Okay, so do you have any questions now?
No, sir. No, sir. Thank
Yeah, I am done for today. Okay,
you. Thank you.
so are you all working on the assignments, or you have lost the interest? Huh?
Not getting time of pieces.
Not getting time. Okay, you are all overloaded operators now.
We don't understand when we will get overrated.
Overloading is fine. Overriding should not happen. Somebody should not replace you.
No, that is what. We don't expect that the override should happen.
Okay,
But we
okay.
are overloaded.
Yeah, I understand. But let's continue our discussion, and let me see if we can wind up this C++ next class, or if you can start with the data structures.
So we might need some recap on the STL, like at the end of the session. Not like you can start off your data structure like
Okay, so what recap you want on C++ only?
vectors and all. Sir.
Oh, okay. No, I'll be covering those things in great detail in data structure. I have not covered those template libraries completely, because some basic introduction of all the data structure should happen. Okay. So that is why I have deferred some details to that point. Okay. So if you want any other coverage of what all has been covered so far, we can have it next class. Otherwise, we can start off with data structure straight away.